Hi, everybody. This is Mr. Folly, and welcome to Podcast 3.3, where we're going to talk about gas math. We're going to talk about P, V, T, and N, their units, and their graphs. So, to start with, pressure's units are atmospheres, my favorite, PSI, used far too often. Oh, get back here. And torr. Okay. Volume here is going to be in liters or milliliters. Temperature is in degrees Celsius. Oh no, that is an awful, awful word. It's not allowed. So, degrees Celsius is not allowed. So, whenever you have degrees Celsius, you have to add 273 to get kelvins. Okay, we're going to look at tables of change that hopefully will clarify things and give you an idea of what's going up and what's going down. Okay, so let's take a look. PV is inversely proportional. So what's that graph look like if it's inversely proportional? We did this in our lab. So pressure and volume. Okay. So that means as pressure goes, see here, pressure went down. Oh, get back here. Why are you doing that? Pressure goes down, volume goes up. They do opposites. Inversely proportional means opposites. It also means that PV equals a constant K. And what we're going to use perhaps the most is P1V1 equals P2V2. So let's take a look at the real math problem. Calculate the missing quantity, assume the temperature remains constant. So if temperature is constant, I'm going to squiggly diggly through here. Calculate the missing quantity, assume the temperature remains constant. V1, that means my initial volume is 123. At 4.56 atmospheres, that means my initial pressure is 4.56. V2 is question mark, so final volume, that's what we're looking for. And at 1.32 atmospheres. So you see how the pressure went down? If the pressure went down and it's inversely proportional, volume goes up. Okay? So that means as I do P1V1 equals P2V2, my initial pressure is 4.56. My initial volume is 123. My new pressure is what I'm solving for. And no, it's not. Ugh. My new pressure is 1.32. My new volume is what I'm solving. So that means when I do this math, V equals 4.56 times 123. Cross multiplication's my friend. And I get 1.32. Where did it go? Seriously? That's horribly annoying. V equals 4.56 times 123 divided by 1.32. And that answer is 4.25. And there you go. So notice how this goes up. 4.25 went up compared to 123 as it should. Sorry. Take a look at the next one. PT is directly proportional. So what does that mean? Well, first of all, it means these numbers shouldn't be here. Whoa, that was pretty good. Let's see if we can erase my scribble. Hey! So directly proportional means as one goes up, the other one's going to go up too. Pressure, temperature. Okay. The other thing that it means is that P over T equals some constant K. And the other thing that it means is P1 over T1 equals P2 over T2. So that, where did it go? So these two equations can be helpful, and we can then graph them out, okay? So let's look at this. What pressure will 2.3 liter container have to get to raise the temperature to 35 degrees Celsius? So if I'm raising it to 35 degrees Celsius, that's my final temperature. Assume the initial conditions I'm sorry, assume the initial temperature of the balloon is 25. Initial temperature is 25. And the initial pressure is 0.95. So I'm going to look for this. Now, it doesn't say anything else about the volume, so that's going to be constant. But notice here my temperature went up. Now, I wrote Celsius, which is a dirty, 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 dirty word. So I can't use 25. I need to do plus 273. That's 298. And I can't use 35. I have to add 273 to that. That's 308. Otherwise, my math won't work. Okay. So notice as temperature goes up, if they're directly proportional, I know that, the pressure is going to go up, which should make sense too in our ring of ping. If temperature goes up, particles move faster, more ping to ping, ping to ping, ping, pings. So let's take a lookie at that now. Pressure 1, so P1 over T1 equals P2 over T2. P1, 0.95 over T1, 298, equals P2, that's what I'm looking for, P2, fine, over T2, 308. Okay. So P2 equals 0.95, I'm cross multiplying here, times 308 over 298. Calculators assemble. 0.95 times 308 divided by 298 is 0.981. So that's a little bit bigger. Did it go up? It went up. That makes sense. The units will match. Let me get back here. My pressure unit up here was atmospheres, so I'm going to have the same pressure unit here. All right. TP is directly proportional. Toilet paper is directly proportional. Pressure and temperature. So again, that means T over P. Is that the same one I just did? P2, TP. I sure did. You know what? That makes it even better. So what I meant to do, let's see, does that mean that, oh, I know what I did. I meant to do V over T. Shame on Mr. Folly. TV is directly proportional. So V1 over T1 equals V2 over T2. So when the pressure is 50 degrees, the pressure, I'm going to change this. Watch this. The volume is 3.00 liters. What is the, I'm going to change this right here. Volume, if the temperature is 75. Oh, man, oh, man, oh, man, oh, man, oh, man. Okay, so the temperature is 50. So my initial temperature is 50. No, it's not. Plus 273 is 323. So my initial temperature is 323. And my final temperature is going to be 75. No, it's not. It's going to be 348. Let's see, that's not right because I had to change it to Kelvin. What did I do here? Remember to change my temperature, Celsius to Kelvin, plus 273. Okay. My pressure, no pressures. I'm looking for volume. So my original volume is 3.00. And then what is the volume? This is what I'm looking for. Now, whenever they leave something out, what that means is it's constant. Constant. Okay. So you see that this went up? Oh, get back here. This went up. So in a direct proportion like this, then my volume will also go up. Okay. So V1 over T1 equals V2 over T2. My original volume is 3. Should check. Original temperature is 323. Should check. Equals my new volume, what I'm solving for, should check, over my new temperature, 348. So V2 equals cross multiplication. 3 times 348 over 323. V2 is something with math. 3 times 48 divided by 323 is, I have strangers that just walked into my room and I don't know why. And then my volume here is, what, liters? Yep, liters. Strangers, why are you here? She's in the room right over there. Welcome to do a melting point lab. So, there you go. Let's look at the next one. Particles and pressure are directly proportional. We'll dodge the math here, but know the graph. And we did this with a ring of ping. Particles, believe it or not, we call N. The unit for number of particles, get back here. Unit for number of particles is moles. Okay? So N and pressure. And this should make sense. If I have more particles, I have more pressure. How much fun is that? Review. Most everything is directly proportional except for PV. Direct proportion graph. Indirect proportion graph. Woo. Up pressure makes you hot. And that is it. We are done. We have learned all the pressure we need to learn. Toot, 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 toodles.